All right, let me make sure my sound is working. I was having issues again with it today. Looks like it is. Yay, celebrations! There's nothing worse than being about to go live and then realizing that your sound is not working. So it's working today. I know last time we had issues, but we had some tech support help from my husband next door. So that was very nice of him. But welcome, everyone. Happy Tuesday. If you celebrated Memorial Day weekend, I hope you had a lovely weekend. For me, it was nice and sunny and warm, and then we ended with some rain, which we badly needed. So it was very nice. But welcome on in. We are going to be working on our home automation app. My name is Megan. I am a teacher and a student success. It's always fun to say that so fast. It's a built-in tongue twister. I'm a teacher and student success specialist here at Treehouse. If you're just jumping in here and you have no idea what Treehouse is, we are a great place to learn how to code, learn how to design. Whether you're learning a new language or you're picking up coding or design for the very first time, we're a great place to take that journey. So you can find me hanging out in the UX design tech degree and in the Python tech degree. So if you're some students popping in from over there, hello. We've been working on a home automation app, focusing right now on the weather connection on the back end. So you may see on the left side here and also on the GitHub repo, I made some changes to the way I had the files organized. Originally, I wanted to organize them in folders and kind of break them up a little bit more, make them a little bit, in my opinion, easier to understand. But one thing I learned, because Python is also a newer language for me, is that Python is a little bit funky when it comes to putting things in folders. And so in order to make working on this program, a little bit easier and hopefully a little bit faster, I decided to kind of remove the folders and just put everything in the one folder. So hopefully that makes this something we can work through a little bit easier. But maybe we'll go into folders with Python in its own live stream session. So we'll see. So one thing I added are some to-dos. If you like the way these are colored, I have a extension here in Visual Studio Code. It's called Better Comments, which allows you, let me minimize this a little bit, allows you to do things like just information, things that are like red flags, question marks, to-dos, things like that. It kind of just like spices up your comments a little bit. So I decided to use them, close, for some to-dos here. So we kind of know what we're working on today. So recap of 2 weeks ago, we worked on connecting to a weather API, which is called openweathermap.org. The one we're using is the 5-day weather forecast, which you can find at openweathermap.org/forecast5. Or you just go to openweathermap.org and you just click on API and it'll list out all the different types and you can find the 5-day there. So we worked on creating a URL with all of our information in it to send over to OpenWeather so we can get information about my local weather, which we got. And the information, if I scroll down, comes back looking like this. So we went through all of this information and we picked out the pieces that we need. So we're going to further make sure we have just what we need, and we're going to organize it in a nice Python class. So to start off at the top, we have our keys, which again, I have on our README of what you need in the key file if you're following along with me. So from last week, if you were following along, you should have this already. If you're following along with us this week, go ahead and download the repo, and then you'll need to add your own keys.py file. And inside of there, I have 3 variables: a weather key, which is the API key from openweather.org, This you have to do on your own because everyone's API key is secret to everybody else. So all you do is you sign up, and it's completely free, and they give you an API key. Then the next variable I had was city, which I put as my city, but feel free to use any city that you want. And then it also had a state, of course, your state. So those are what you need to have in your keys.py if you're following along with. So at the top here, I'm importing those variables, weather key, state, and city, because when we get our data, it's a 5-day forecast. It has a date and time stamp on it that says what day and time it relates to. So we want to make sure that we're getting the right days for our weather app, because we want to get today's weather in a little more detail, and then we want to get very minimal information on the next 3 days. I think it's, the next 3 days. So 4 days total. So we're going to be working with date time today. So I'm going to add our import here at the top to grab our date time information. And I like to break it up. Some people just do import date time. I like to break it up and call specifically what I'm importing. So I'm going to do from date time, import. What do I all need? I got date, got date time. Yes, there is date time, date time. This is why I like to import it this way, because it does get a little confusing when you're typing date time, something. So this is my preference, but feel free to do it however you like. We're also going to need time delta, which is how we do kind of some math to check differences between days and times. And the last one is time. So those are the ones that I'm going to use. Control S to make sure to save it. I have this already written, so if you're like, what is she staring at? I'm staring at my actual code, so I make sure I write things that actually work, because that makes this go a little bit smoother. So the next thing I had was, that's for something we don't need anymore. So, yep, this is all we need. We need our keys, our date time, and our requests. Done. So now we're going to start building our class to hold the logic. So I'm going to do it right underneath the to-do, because that's the way I like to do it. Instead of doing it underneath all three, I'll kind of break it up by each one. This I'm going to leave that we had from last week just as reference, because we know this information gets what we need. And if you hear sounds, my dog is here with me, and she is chewing on a bone. Actually, I'll show her off real quick because I think she's so cute. She's a little heavy, so give me a second to muscle her up here. Jump through. She's got a cheesy bone that she's going to town on over there. So if you hear chewing sounds, that's her. And then my husband's in his own meeting on the other side. So my apologies if there's background noise today. Sorry, little doggy sidetrack, but jumping back in. So we're going to create a class. I liked doing it this way when I was originally building this out. I feel like it's kind of like a component, creates its own like component. Feels like it was kind of organized all within this class. And it felt like the right thing to do to me. But you can absolutely do it without object-oriented programming. But I'm going to show you the object-oriented programming way. Can you hear my breathing, having to lift that dog? Boy, I have not been using the quarantine time well to work out, and I need to. All right, so we have class, and I'm just going to call it weather. You can put the parentheses in if you like, but you also don't have to. I like to, just in case I come back to add something, they're already there, but you don't have to put the parentheses there if you're not putting anything in the parentheses. So we have our class. Inside of a class, the first thing you usually want to put, please don't restart my laptop, that would be great. It keeps popping up. That's always like one of the most like anxiety driven things is when your computer's like, I would like to restart now. And you're like, no, thank you. And then 10 minutes later, it's like, I would like to restart now. And you're like, please don't. So if this goes down at some point, the computer decided to restart without me, and my apologies. But it should be fine. So the first thing we want to put in here is our init. So this is going to be a dunder method or double underscore. You can see a whole bunch of ones there. And there's the one we want right there, init. Looks like that. So the init method is essentially initializing, which is a big word for saying when you create an instance of this class, or when you create a class piece, a class object, this is what I want you to do when that creation happens. So the initializing is, hey, class, when you're created, please do these things and make these things. So you're telling it what you want it to do when it's being created. So first thing you're going to want to put in there is self. And I did bump up, side note, sorry, I'm really scatterbrained today. My apologies. I did bump up the font size for both the code and the console, but if it needs to bump up a little bit more, just let me know. But they're both at 20 font, and looking on my screen, I feel like they're large enough to read easily, but if I need to bump up bigger, please let me know. I found it in the settings, so I can do that. So I'm not going to have anything else in self. If I was going to pass in some information when this class is created, I would want to put that here, like maybe like a location or something. I would put that here, but I'm not going to, for what I'm doing, I'm not going to have anything be passed in. So inside of the init function, I am going to break down each day's weather information into its own dictionary. I like the idea of having it as key value pairs instead of like a list where it's just a list of stuff in there, because it's a little bit easier to grab the information that you want and to make sure you're grabbing the information that you want. And it's a little bit easier on readability because in a dictionary, when you're trying to get something, right, you can say temp, and then I would get back the temperature of the day. Like wind speed, I'm going to get back the wind speed. So I think it's a little bit more readable, so I'm going to break it up by each day. So self, which just says that when this is created, it's going to create this variable, self.today. It's going to be an empty dictionary, and I'm going to do one for the next couple days. So then I have self.tomorrow. Hopefully I spelled that right. It's always a fun adventure in spelling when you're doing this live, and I'm going to scroll. Self dot, and then how did I do this? I did day P2, which is today plus 2 days, if that makes sense. If you want to change it to something that makes more sense to you if you're coding along, please feel free. Feel free to change things as we go through. I'm not going to check your work and make sure that you're doing the exact same thing or anything, so please feel free to edit as you need to. And then, of course, last day is self dot, day underscore P3. So today plus 3 days. So today, tomorrow, the day, because I wanted to do, because today is pretty easy, like today, tomorrow, but then can't really do a variable name, the day after tomorrow because it's just too long. So that's why I did day P2, day plus 2. That was kind of my way of trying to make it understandable, but still short enough that it's not like a really annoyingly long variable name. So that's what I have right now. If you come up with something that you think is a better one, let me know. The last two things I have is self.date, which is going to be date.today, which is a function call. Because I want to get today's date, because when this runs, I need to get what today is so I can get specifically the weather for today, and then I can add one to that, to this date to get tomorrow, then add 2, and then add 3 to get the information. So that's going to help me get that. And the last one is self.time. And I'll talk more about why time is important. So this is going to be using just time. This is also a function call, and it's going to be 15, comma, 0, 0, 0, 0, comma, 0, 0. Okay. She's doing a little stretching back there. So why time is important is because when we get our information back from the weather API, we are getting, let me see where it says it so I can show it off, 5 days worth of data every 3 hours. Or sorry, we're getting every 3 hours for 5 days. I think that makes more sense. So what that means is if I were to run it right now, it's almost, for my time, it's almost 3 o'clock. So I would get 3 o'clock, 6 o'clock, 9 o'clock, so on and so forth for the next 5 days. So what I've decided to go with, and this is back from a class I took in college, which was atmospheric science. I'm using 3 o'clock every day. The reason is typically 3 o'clock is where your weather or where your temperature peaks. So if I need to plan for my day, I probably want to know, like, especially coming into summer now, how hot, like the hottest part of the day, how hot is it going to get today? You know, do I need to grab some sort of umbrella because it's super sunny and really hot? Do I need to, you know, make sure I'm wearing shorts or something, you know, a little more breezy? So that's why I'm doing 15 o'clock. So I broke it up into date and time, but we could also combine this into a specific date time. But I thought breaking it up might be a little bit easier to understand. So we have all of our variables done. So that is our init class. The next class I'm going to get is kind of going to, I'm going to break this up into 2 functions. So I'm going to come here. I'm going to tab back over, so I'm still within my class. I'm going to go define for my function, and I'm going to call this get data. And this is going to take self, because it will always take self when it's a class, a function within a class. And then I'm going to pass in my key, which is my weather key, my city, and my state. So this is where I'm going to do the API call and actually call that URL to get the information back. So I have that. And then now I can scroll up, wrong way, scroll up to grab this right here. And we're just going to cut it. This is why I left it here too, just so I don't have to repeat it. So Control X. I'm going to, oh, should be 2. There we go. Make sure I'm tabbed in. Control V. And so now, because my variables that are coming in are called key, city, and state, I'm going to need to come over here and I'm going to need to change weather key to just key. That way they match up. So we have our key, city, and state. So that's going to get our response. And, oh, I don't know how to do it on this keyboard to get to the end. So we're just going to do that. Okay. So we have that. So this is going to get us the information. So for right now, I'm just going to show you what it's doing. So I'm going to do a print call, and we're going to do response.json, which is a function call, and then we know we need the list, which if I scroll back up, I'm running this part up here when we were doing our prints 2 weeks ago. So this is just to show that the information's coming in. I'm going to kind of jump down here a little bit, and I'm going to do a dunder main statement, which means if dunder, name equals, I keep hitting that caps button, main We're going to do weather equals weather, and I'm going to call that the class. So this is going to create our own piece, our own object from that class. And then I'm going to do weather dot get data. So you can see this now pops up because weather here is an instance of this whole class. So now I can call this function that's inside of this class. So get data, which is a function. And then I need to make sure to pass in my information. So I need my weather key, my city, and my state. I'm going to save. And the reason we put this inside of an if statement, which we call this statement the dunder main, is because eventually we are going to import this whole file into app.py. So when we do that, we don't want this stuff to run because we're going to run our own versions of this stuff in app.py. But for right now, when I'm, testing stuff out, making sure stuff works, I want to run the weather file and make sure it's working. So if I put this inside of a dunder main statement, then when I run weather.py, it'll run my functions down here and it'll work just fine. So it's kind of like if I'm running weather.py, do this stuff. If I'm importing it into app.py, do not do this stuff at all. And that's what the dunder main statement does in a very basic level. So let's make sure this is working. Make sure I saved it. It's saved. So, sorry, I might sneeze. Nope. Okay. Okie dokie. So I need to get into our pip environment shell. Oops. Shell. Cool. And then I'm going to run pip environment run python weather.py. Oops. Oh, yep. So this is why it's always good to run. So what it's saying, in case you don't have a ton of experience with errors in the console, this is a great example. So what it's saying is have a traceback. It's saying inside this file, which is the only file we ran, on line 6. So I could scroll back up to line 6. So this line right here. And it tells me right here what the line is, which is this exact line. And it says name error, name RSEP or response is not defined, which it's not because I copied and pasted our response down here. So when it tried to run the file, it goes top to bottom and it can't run these. So I'm going to, I want to keep this because we're going to need that information later, but I'm going to comment it out, which in Visual Studio, a fun tidbit for flipping between comments back and forth is highlighting everything you want to comment out and doing on Windows, you want to do control and then this way slash. Oh, that might be backwards for you all. Backslash, right? Yes, backslash is the one that goes like this. That one. If you can see what that one is right there. It's kind of hard to see. Maybe if I type it down here. That one. The one that goes that way. But when nope, because my camera's flipping it, so I'm having a hard time trying to model it with my hands. But it's the slash that goes this way. That's what you want to hit on your keyboard. And on a Mac, it should be command and then the slash. And that allows you to toggle things in and out of being comments. So we did that. Now down here in the console, I can just push the up arrow, which brings back the last command that I put into the console, and I just run it again. So, ta-da! That tells me it's working. So, let me scroll up. You can see this is all of the information. So this is not what we broke down last week. This is everything. So I just kind of wanted to show that it is working. It is getting all the information that we need. So, starts back up there at the top. Okay. So we have our information. So now what I want to do, I grabbed it. I want to organize it. I decided when I was building this that to break that up into two functions, because getting this part kind of seemed like its own task, and then organizing the information seemed like its own task. So to me, that felt like it would be better as two different functions. So what I'm going to do is I'm going to create the function first, and then I'm going to come back and edit this last line. Boop. Tab. So my next function is, you probably guessed it, organize data. I like to try as much as possible and create function names and variable names that are telling us exactly what they're doing, because it makes it so much easier to read. The more you do this and practice this in your own code, I promise you your code will be like 10 times easier to read. It's really easy, especially when practicing, to just be like def, like my function, and then keep going. But then you're like, oh, wait, I don't remember what my function does. And then you have to like dig into your code, and it takes longer than if you just go organize data. So this is going to take self, and it's going to, of course, take the data because it's organizing it. So it needs to have access to it. So inside of this function, I'm going to move this down here, just so you all can see that it's still running, it's still working. And in order to call another function within a different function in OOP, we are going to do a return self dot organize data. And this is going to take our response dot JSON and our list. And so here, all I need to, instead of printing this, because that's what's coming in, that's coming in as this, as data, as that variable. So print data. Let me save that out, and I see a question popped in. Any recommendations for someone who is getting into Python coming from the front end? Welcome. Welcome to the world of Python. I also came from JavaScript, and I learned Python second. I do think that learning a new language after you've learned one, especially any language, but in your case JavaScript, is a lot easier in my opinion, because a lot of the things are called differently. Like this is called a dictionary. In JavaScript, I literally cannot remember what it's called, but I'll do a different example, one that I remembered. So in Python, this up here is called a list. In JavaScript, it's called an array. So there are a lot of things that work very similarly, if not the same way. They just may be called different things. So I totally recommend jumping into Python, starting off with Python basics, and you may even be able to kind of like skip through or kind of like speed through some videos because of those similarities like I was just talking about. So I think it's good to have a couple languages under your belt. Makes you more versatile. And if you front end, obviously you're focusing on a lot of the stuff that people are going to see. With Python, especially with what we're doing right now, this is all on the back end. So sometimes people don't like switching from the front end to the back end, because on the front end you get to see, right? You get to see what happens on your, with your HTML and your CSS and your JavaScript. You get to see what happens on your website or on your, whatever you're creating. But on the back end, it's all here, down here in the console, right? It's all down here in this stuff. If I can highlight it so you can see where I'm talking about. So it's all here in the console. So it's not as, you don't get to see as much of what you're doing. It's more just like stuff in the console that's text-based. But I like both. I like getting into the back end because I feel like I get to worry about being more like logical and problem solving. And then on the front end, I feel like I get to be more about making things like function and like interact really cool and look really nice, and kind of focus on that aspect. So I would totally say jump into Python, start with Python basics. which we have in our Python tech degree, and we also have in the Treehouse library. And those are both, that's a great way to see what you think of working in the back end, because I know some people don't like it, but you could. It has, both have their ups and downs. And then just, tackle it, see what you think. And then from then on, you can jump into more and more intermediate and difficult Python things. And I think you'll have a lot of fun. Resources for beginner projects with Python. Great question. The Python tech degree goes from very, beginner projects and kind of works you up. So that's a great option. If you're looking for something kind of more, maybe smaller, maybe little pieces, games are always a great one. Things like trying to do Hangman or Tic-Tac-Toe or Guess a Number, which is actually our first project in the Python tech degree, is number guessing game. Games are pretty easy. Other things that are fun to play around with is depending on how far you want to go, you can do kind of like what I'm doing, working with information from an API and practice printing it and grabbing information. There's quite a few different things that you can grab from there. A great place to look for lots of great information on projects and other things. Obviously, we have a ton of great Python courses here at Treehouse. I like to also look at medium.com. They have a lot of great articles and things like that that show off example projects, more explanations of different like pieces of code. If like you get confused on a certain piece, sometimes it's helpful to research that specific piece. But those are places that I would go, and those are some projects that I would suggest. I always suggest, besides games, things that you already know about and understand, and then trying to get those to work in here. For example, a small project I was going to be working on my own time is an exercise project. Like I was just talking about trying to lift the dog and how out of breath I was. I was going to get a list of essentially create a list of different workouts, like different arm workouts, whether it's, like presses and things like that. Then workouts for like your abs and your back and your legs and all that stuff. And then randomize it. So picked a random arm workout, a random ab workout, a random back workout, a random leg workout. So I could run it, and then I have a randomly generated workout to do that day. And then the next day I could run it again and have a new one. So there's always different ways to incorporate things that you may be currently interested in. If you love to play video games, but you're like, may have a lot of different ones to choose from, you're not sure, you could create a program that lists out a bunch of different video games and randomly chooses one for you to play. But there's endless possibilities if you just start noodling on it. But definitely Googling, example projects is always a place to check out too. So I hope that answered your guys' questions. So I'm going to run this again. So it might, oh no, it should just print once because I have it once. So I'm gonna scroll through the data. There we go. Just pushing up on the keyboard because I'm just running the same file again. Oops, I'm not saved. That's what that little bubble up there means. So I'm gonna make sure I save. Okay, now I can run it. And I get the information again. So that's telling me that this is sending the information to this function, which is then printing it. So that's all working. So that was just me checking to make sure that that's going. So we actually don't need this at all. So I'm going to delete that. And I'm going to start breaking this down. So we have for data point in data. So this is a for loop, which means it's going to loop through every item in this list, which if I scroll, oops, I keep wanting to scroll the Mac way because I use the Mac most of the time. Let me scroll up here to the top. Okay, so we can see this symbol right there. I know it's kind of small. Hopefully you can see me. I'll kind of put my mouse over here so you can see it and follow me over. So that bracket means that this is a list. And this item right here, we go all the way to weather, clouds, wind, rain. Here's the end of it. So all the way to there. That is one item in this list. So what I'm doing is I'm going to loop through each item in the list. So that's going to help us find the ones that we need, and then the ones we don't need, we can just ignores them. It's just like, we don't need you. Please go somewhere else. So getting into our loop. So inside here, I need to convert the date time. So you can see the first thing that they give us here is this date time. But we want it in a different format, so we're going to convert it. So I'm going to do convert. I'm just do converted. I'm trying to keep it the same from what I have written over here. So converted equals date time dot strp time. So this is strp time is what we're going to use to convert our time from this seemingly random number. It's not random. It actually means a specific day and a specific time. But no one that I know of, if there's someone out there that can look at these times and instantly know what day and time that is, I'm going to be really impressed. But most people, when you see that, you're going to have no idea what day or time that means. So we're going to convert it so it's a lot easier for us to read. So I'm going to scoot this a little bit closer, a little bit far over here. And of course, I'm getting myself caught up. There we go. Okay, so we need to get our data point. So remember, when we're looping through our data, one piece, which we pulled out was this right here, one item in this list, one piece of data in this list of data pieces, is now called data point. So one singular point. So I'm going to use that, and we need to get our, what is it called? dt underscore txt. And, oh, it didn't put it inside the parentheses. X, V, there we go. So this is actually, so that's the date time. I'm actually grabbing this down here. So this is a little bit easier to read. So this is saying it's 5/26/2020. So today at 2100 hours, which is 11 o'clock, right? No, there's 24 hours. I'm really bad with military time. So let's see. Noon is 12, 8 o'clock is 20, so it's 9 o'clock. 9 o'clock. See, we get there. We'll get there eventually. So we're actually gonna take and convert this information here. My apologies on getting stuck up on the date time earlier, but so we're just going to break this up. So we have this, and then we need to tell it the format that it's in, because right now it's like, okay, you gave me this information, but like, is this the time? And that's the minutes, and that's the hours, and that's the day. It doesn't know. So we have to tell it that this is the year, month, day, hours, minutes, seconds. So we have to give that information to this function. So it also needs to be inside of a string. We're going to do the %, capital Y. That stands for the year. And then it has a, keep losing my place. I need to like highlight where I am. There we go. It's much easier. Then just like it has here, the dash, I need to tell it there's a dash. And then we do % little m for the month, dash, % little d for the day. And then just like there's a space in between, I also need to do a space. And then we're going to do the time. So %h for the hour. And then like it shows there, we have colons now. So colon, %m for the minute, colon, and then %s for the seconds. So that is our converted time. So we've converted the time into a format that we can use more easily. So now I'm going to have date, which equals our converted time dot date. So this is just going to pull out the date, and we're going to have our time. And this is just to break it up so it's a little bit more easier to read. There's obviously other ways I can do this to make it less code, but I wanted to break it up just so it's a little bit easier to see the pieces of what we're doing. So essentially, I took this whole piece and I'm breaking it up into the date and into the time, into two pieces. And you're like, well, why didn't you just split this? I could do that, and then I would just have to kind of run this twice to convert it into date and time. So instead, I converted it, and then I'm splitting it, but kind of the same thing. So then converted dot time will give us our, might need the right word there, will give us our time. So the whole reason we need this is so we can do if. So an if statement is a conditional. It's essentially if this thing that I'm about to type is true, do these things that I'm about to type underneath. If it's not true, then don't do anything. So if time, which is this time here, if time is equal to, and I'm going to scroll up so we can see our self.time. So if our time is 15 o'clock, remember, we only want to grab the data points that are at 3 p.m. because that's when the temperature is usually at its highest for the day. So if it equals self.time, then we are going to break it up into its individual days and save the information. So let me check our time right now. Okay. I just want to make sure. I kind of want to get this finished today so that we can move on to the Google Calendar in 2 weeks. But so this is going to say, we're going to check every data point. We're going to do a little time conversion. And then we're going to check, does that time that's here for each data point, does that match the time that we want, 3 p.m.? So if it does, if it's the time we want, then we need to save our data. So if the date, so the converted date, which is coming from the same place, so if the date equals self.date, then we're going to save the information we want to keep into our, scrolling up, into our dictionary items. So we're saving all of our information into our dictionaries is what we're working on right now. So if the date listed equals today, then we're going to do self.today, and we're going to add an item called, a key called temp for temperature, and that is going to equal the data point main temp. So if I scroll back up, it's exactly what we worked on 2 weeks ago. So you see the same thing here from data point in our data. We're grabbing our temperature. So we're just using that same information that we used earlier or 2 weeks ago. So we're grabbing our temperature information and we're saving it to a key called temp. So then self.today, we also need to get the weather equals. So you can type it, or if you want to, you can scroll up and you can just Control C, Control V, and we have our data point, weather 0 main. And we already checked it last time. We know that's the right drill down to the information we need. And then the last piece we need is the wind speed. So self.today, we need the wind, no space. And we need the data point, And this is going to be wind and speed. So that one's pretty easy because it's wind and then speed for drilling down. Makes it a little easy. Okay. So we have today done. So now we need to do tomorrow, the day after tomorrow, and the day after that. So the next 3 days. So this next part is going to be very similar. It could be broken up into its own function, but I also felt like for right now, I'm going to leave it here in one because it's all within organizing the data, all within that same kind of task. But you'll see what I mean when I start getting into this. So now we need to check if this equals tomorrow. So we have, if it equals today, give us this information and save it. So now we're going to check if date equals, and this is going to be where we use our time delta because we need to add a day. So in parentheses, because we want the parentheses means I want you to do the math here first and then check if it equals the date. So it's going to do a little math for us first. So self.date, and this is going to be plus, doing a little math, and this is where we're going to do our time delta, and we're going to add days equals 1. So that's going to add 1 day to our date. So it will be, instead of 5:26, it'll be looking for 5:27 at 3 p.m. Just making sure. So then this is self.tomorrow, and we need to save a temp here, and we can grab the exact same piece. Actually, we can grab both of these. Control V, and then we're, instead of today, we need this to be tomorrow. Make sure that I have that right. Okay, before I get too far. So this is what I mean by repeating, because anytime you see yourself copying and pasting, you usually want to break it up into its own function because you are repeating your code. You're no longer being dry. Which, if you don't know, dry is what a lot of programmers talk about, and you're like, I've heard it, I don't know what it is. Dry is don't repeat yourself. So anytime you repeat yourself, you your code typically gets a little bit bigger. So this is something we could turn into its own function, because I'm literally going to do 2, and this is become day plus 2, day plus 2. That's all we're changing. For right now, I'm going to leave it broken up just in case that helps some of you think through what's happening here. And then we can kind of refactor later and show how we would make this code even drier and quicker. But for right now, I'm going to leave it broken up just because it might be a little bit easier to understand what's happening. So then this is our day plus 3. So you can just need to go 3, 3. So for today, we have the temp, weather, and wind. And then for the rest of the days, we only need the temperature and the weather. We don't need the wind speed. So that is going to get and save all of the information that we are grabbing from the API. So the last thing I want to do is return the information. So I'm going to scroll up. So we need to be at the same line as this 4. So I need to go tab, tab, just to make sure I'm in the right spot. And you can see the colors too. The colors kind of help. So I need to be right before this purple. So return, what's self, nope, wrong letter, self dot today, self dot tomorrow, self dot day plus 2, self dot day plus 3. So now we're going to return all of that information because we have now organized it into those 4 dictionaries. So we're going to return it here, and if I come back up, it's going to come back here, which is also going to return it. So essentially what this function does, it's going to call the API, then it's going to call the organized data. The organized data is going to run, organize the data, then it's going to return the information. And then when it comes back up here, then this return will call, and that is the end of what's happening here. So if I scroll down here, now I'm going to need to, because it's returning, I need to print this so that we can actually see it in the console. There we go. Control S. So let me scroll all the way down here. Okay, so now I'm going to run the same thing again. So pip environment run Python weather app weather.py. Hit enter. And you can see there's nothing for today because it's already past when it would give me the 3 o'clock information for today. So that's why the first one's empty, which is totally fine because we're going to make sure and set this to run in the morning so that we do get today's 3 p.m. information. Because in a few minutes, it is 3 p.m. here, so it's not going to give me the information from the API. So that's why it's empty. So if you see that because you're running it yourself, you didn't do it wrong. It's just the weather API doing it. So then you can see tomorrow, the temperature at 3 p.m. is 66 degrees, and the weather is cloudy. And you can see it's cloudy today. Yeah, it's cloudy today, cloudy tomorrow, cloudy Thursday, and then Friday we finally get clear weather. So that's great news for me. But right now we are done with our weather.py. Like I said, there's definitely some places where we can refactor and make the code a little bit drier. But I'm going to leave it as is for right now. We can come back and do that because that might be a fun thing to go through and do as a special like refactoring live stream so that we can do that together. But we've done the weather API. So some things that I'm going to add in here, I'm going to remove this to do because we did it. Same here. Did that. And then I don't need any of this anymore. And I need 1, 2. Oh, get rid of that. There we go. Just to clean that up a little bit. So we have our imports. We have our class. We have the init defined. We have our 2 functions. And then down here, I can clean this up a little bit. So we have 1, 2, and then we have our Dunder main. So all cleaned up. So there's a couple things that we can do. Like I said, this part right here is repeated. That can be turned into its own function. Another thing that we're not doing right now is what happens if we call the API and it's like the API is down, and it sends us back no information. What should we do then? So that's something else that we can that we'll worry about down the line. But please feel free, as always. Is the Google Weather API. What we're using is openweather map.org. I'm actually not sure where it pulls it from, but it is correct because I have been looking at my phone to make sure the weather that it's bringing me is the weather that my phone is at least telling me. So, not sure exactly where it says. Oh, Google Weather-based campaign management. So maybe coming from Google Weather. But yeah, so we're done with the weather API. Like I said, there's little tweaks and things, but we'll save that for refactoring when we get done. So in 2 weeks, we're going to be doing Google Calendar, which we'll do here in gcalendar.py. So I will add in, like I did before, some to-dos here, and then update the repo so that if you want to jump ahead and you want to try and tackle this on your own, feel free. And then in 2 weeks, you can see how I tackled it. Otherwise, feel free to wait till 2 weeks from now and we'll start it up together. I don't think currently I'm using my Google Calendar very much, my personal one, so I'm going to have to put in some fake events so that we actually have information to pull out of it. Otherwise, it just might not look like it's working if there's no events to pull out. But we did it. We got our weather app portion of our home automation app working. We have the information we need coming out. And then once we finish them, we'll jump into app.py and start pulling all of the information here into one place. So this will be where we call our our weather function so that we can get the data. We'll do that in app.py. But anyways, I hope you all had fun. I hope you've been enjoying getting the weather API working and the information connected. Feel free to play around with the information, try changing the time, changing the dates, changing locations to your heart's content. So feel free to play around with it. But like I said, in 2 weeks, we'll jump into Google Calendar API. So time for me to start working on that so that I can teach it to you in a couple weeks. But anyways, I hope you all had a wonderful time hanging out with me today. I always enjoy hanging out with all of you and getting your questions. Please feel free to always reach out if you have any questions. I'm more than happy to answer them. And I will see you all in 2 weeks. So don't forget, Treehouse is an awesome place to learn whether you want to start out coding or designing for the very first time, or if you want to learn a new language. It's a great place to try it out, dip the toes in the water and see how it feels. So hop on over with us at Treehouse. I'm hanging out, like I said, in the UX design tech degree and in the Python tech degree. So if you stop by there, you can say hi to me. But keep being awesome. Keep coding. Good luck and have fun. Have a great rest of your day, everyone. Stay safe. Bye.